Hello everyone, welcome back. So today we will see how the Kubernetes works, right? So we just need to understand the Kubernetes architecture, right? Because before we dive into the Kubernetes hands-on, right? So first we need to understand its architecture, like how exactly the Kubernetes works, right? So we can think of the Kubernetes as a kind of brain plus your body, right? Like brain is your control plane, right? Because if I talk about that very high level view, let me write here. This is the very high level view. So for me, there are only two layers, right? One is the control plane, which is, I would say, your brain. And the second one is your worker nodes, right? Worker node is something that kind of your, let's say the body, right? Or maybe you can say that the actual work, right? This is that control plane and the worker node. It's body parts, I would say. If I talk about in layman terms, so it is body parts, right? So what exactly is happening is control plane is kind of the who manages the cluster, right? Because since similarly in our body, our brain controls our body, right? So in Kubernetes cluster also, control plane is something which control your or your manage your cluster, right? And the worker node is exactly the body parts like which exactly do your work, right? So similarly in the cluster also, these are the place where your application actually runs inside the pods, right? So let me just give you one line intro. What is pod? Pod is a very small entity, right? Small entity, or I would say object in Kubernetes cluster, right? And it's a just a wrapper of your container. It can run more than one container. That is also possible, right? So as of now, just need to understand what is pod. Pod is exactly the place where our image is gonna run, right? What is our image? Image is just a code, right? It's a bundle of your application which you are running inside your cluster, right? So this is the pod, right? So these pods will gonna run on the worker node where your application gonna run it, right? So they, what is the happening behind the scene is control plane and worker node, right? They are communicating constantly to each other. Why? Because they need to ensure desired state equal to current state. So that's the main goal of your this, right? Why? Let's say you have defined your pod will be running, let's say the two replica or maybe two copy of your container should be running at every time, right? But who will take care of that that whether at a given point of time the two instance of a particular container is running, right? That's the part of the control plane, right? It constantly checking that, asking the worker node whether I have a desired state is two pods at a time should run and how many run is currently running, right? Then worker node reportedly back, okay, as of now, due to some reason, only one container is running, so it will instruct, okay, spin up one more, right? So that's how that it works, right? If I'll show you the architecture, so this is something that the drawing I have created here. So on the left hand side, you can see this is the control plane, right? And on the right hand side, I have given only one worker node, right? But you can have multiple worker node and multiple master node as well, right? I mean, three master node and the multiple worker node you can have, right? So what is happening is the key component of the control plane is four. One is the API server, right? Second one is the at etcd. Third one is your control manager, and the fourth one is the scheduler, right? So what exactly they do, right? I will explain. But on the right hand side, if you see the component of the worker node, they have only three. One is the kubelet, second one is your kube proxy, and third one is your container runtime, right? It could be cry or docker, right? But as of now, in latest version, docker is not there, so it is container d it is using, right? So this is the entire cluster architecture of Kubernetes, right? On the right hand side, you can see from the user, they are trying to access the application, right? Whether it's via computer or whether it's via mobile, right? They can directly communicate to the kube proxy here, right? And here is your administrator sitting and using the kubectl binary, it can interact your cluster and manages it, right? So let's understand what all these key components are. So first one is your API server, right? So API server is a kind of front door of Kubernetes, right? Or before that, what we will do is we will just understand in the normal analogy, right? So I will give you a small example here, right? Let's understand via analogy, right? Like I'll just try to compare it with some real-time scenario, right? Let's say API server, right? This is the component of your control manager, right? Control plane. This we can consider as a CEO or HOD of your office or department, right? Second one is the etcd. What is etcd basically? Etcd is a key value store, right? Or we can say it is a kind of filing system, right? Or maybe a store where we can store everything, right? The third one is scheduler, right? So scheduler is what? Scheduler is, let's say, that which schedules your pod actually. But in real time, let's say it is HR manager, right? Who is assigning the task. And the fourth one is, let's say, controller, which actually controls your pods, replica set, nodes, and everything. But in real time, it could be your supervisor, okay, or maybe you can say it is your manager, right? On the right hand side, worker node, we can understand it is a kind of, or I would say it is reception, okay. Let's take that way. And this CEO and HOD, right? I will take it as a control plane. And this is your worker node. Here I will take it as a employee. And this is your kubelet. Let's say it is your employee. And this is your kube proxy. Let's say it is your office network, or maybe your email client, right? Outlook or something. Then the next one is your container runtime. And this is your, let's say, the tools, or maybe let's say laptop, right? Let me explain you with this how it is looks like in this scenario. Okay. All right. So what is happening in real world, whenever you are getting a new instruction, right? Or maybe that if you are talking to some company where you are just saying, okay, I need to finish that particular project or something, right? You directly reach out to your reception, right? So similarly, in Kubernetes cluster, API server is something that the entry point of your cluster, right? If you want to interact with your cluster, right? Being an administrator, if you want to interact, so what you can do is you can use a kubectl binary which can directly integrate with or interact with your API server, right? So API server is a, you can think of the reception, right? Like it is in any office, whenever you enters, right? Directly you reach out to there. So similarly, API server. Second one is the etcd. Etcd is nothing. Etcd is just a key value database, right? It is distributed key value database where whatever the other object or other entity or other properties of your cluster, right? Everything will gonna store in this etcd, right? So it is gonna store your cluster state, it is gonna store your config, secret, port definition, what is the current state, what is the desired state, what is the replica, everything will gonna go here, right? Like whenever you are running, creating any pod, right? Its definition directly went to save, directly saved to etcd. That's how that right. So similarly, in the real time, whenever you are doing something, right, you are filing that you are storing, or you are writing something that on paper or something, right, then you are storing those, because you know that if tomorrow if you need to understand, okay, what exactly I have done, you can just go through those files or papers, and you come to know, okay, that was the stuff, right? Similarly, if something goes wrong and you need to restore, which we will see further in our course, If you need to restore your cluster, so etcd has all information like how your cluster was configured, right? What was the port running, what was the config, everything you can just directly restore from here and it will be up and running, right? Second one is the scheduler, right? Scheduler is something which decide, right? Which gonna decide that okay, on which node a new pod will gonna run, right? Because it looks a resource availability on the worker node, like how many CPUs you have, how many RAM you have, what is the whether if you have any label or maybe affinity rules are applied. Don't worry all about all these terms which I'm just using here to explain you, because this is something that we will gonna discuss in our course, right? So scheduler will just decide, okay, which node should run a new pod, because it knows I like that particular node is having how much of compute power, what is the state, is there any particular affinity rule or what is the state toleration, taint, right, or affinity rules, labels, whatever you have applied, right? That basically on the basis of that, the scheduler will decide where you. Similarly, in the real time, basis on your quality, right? Basis on your knowledge, your HR task will assigning the task, right? Because you know that you can write a code in Python. Someone can do with good with Ansible, right? So that basis on that, the task will be assigned. On the left hand side also, scheduler will do the same thing, right? The fourth one is the main component is the controller manager, right? Because it gonna run a various, it is not a one thing, right? Because controller manager is having a various controller behind the scene, right? Because it constantly watches your cluster, right? Watches your nodes, what is happening. Like we have one of the component is node controller, right? Which monitors the node health, whether that your node is ready, whether your node is not ready, if it is ready, how much CPU you have, how much RAM you have, everything will have this. Similarly, we have one of the other thing is replica controller, right, which ensures that okay, how many right number of ports you are running, right, whether it matches your desired state with the current state or not, right? We have the endpoint controller, we have the ingress point controller, so all these things we will discuss, right? Similarly, in the real time analogy, your manager will watch you that okay, what you are doing, what are the tasks, whether you have assigned, how much you have done, what is the state of that task, right? So you can relate that thing, right? If I come here on the worker node, okay, this is a worker node. Okay, it's not coming, but anyways, I will just try to. Okay, now we're good, right? So on the worker node, you can think of the employee, right, which is the kubelet service, which generally what it does is it is just a kind of agent which gonna run on each worker node, right, which directly talk to your API server and ensure that okay, whatever the ports you are instructed, and I will ensure that much of port is running, whatever you have expected, right? If any port dies, right, I immediately inform the API server and API inform check with the etcd, okay, what is the state of that particular pod. If that is gone, then at the same time a new pod will be spin up, right? So in the real time also, kubelet is a kind of employee which constantly working, and whatever the issues you have, you will report back to your reception or maybe the controller or the manager, right? That is thing. Queue proxy is something the network, right? Like how you are interacting with other people, right? Maybe you are directly using a MS Team or maybe Outlook or some other email client, right? Where you are just exchanging your information, right? You're interacting or you're contacting the other people, right? Maybe it is within the same department or maybe it is from different department, right? So similarly, queue proxy is nothing. Queue proxy is a kind of network, right? Which is across all your cluster, right? It, you can see that this oval shape behind these you have the queue proxy, right? So it ensures that okay, right port gets IP and it gets the right IP whatever you have defined, if you have some network policy or something, and whenever the user is trying to contact your application, it come via queue proxy only, right? Similarly, that email comes to you. Container runtime is nothing. Container runtime is the actually kind of engine which spin up or which maintain or which runs your container, right? It is the it can be containerd, it can be cryo, right? Because Docker is something that maybe it is not used, right? But that is actual that machine which you work, like the laptop, right? So that is the analogy. I hope that is helpful for you to understand this Kubernetes architecture. But yeah, trust me, guys, these are the main component which normally a controller manager runs, and this is something that on the worker node it gonna run, right? So this is something that we can understand. Okay, so I am on my master node. So here you can see that I have the my cluster is up and running, right? Master node is ready and cube node 1 is also ready, right? So let me show you kubectl get ns. So I have here default 4 namespace, right? What is namespace? We will see that that is just the isolate kind of room inside your system, right? Where different resources can run, which don't want to interact to other components, right? So let me show you get pods hyphen n just to specify the namespace, right? I just want to show you what exactly we have up and running, right? So here you can see the component which we discussed, right? So here you can see I have my etcd running, right? That is on control plane, right? I have my API server running, that is also on control plane. I have my scheduler running, that is here, right? And there is one more thing, that is something called okay, API server control manager, right? Because this is the control manager which talks or which will take care of your node health. Here you can see the status shows ready, right? So that's how that it can interact with your worker nodes, right? So these are the main components or main pods running inside the kube system, right? We have other kube node lease, kube public, and default, which is just you can create a new namespace as well. There you can deploy your different application, right? Which you want to keep the isolate from the other applications or stuff, right? That we will see going forward. But as of now, I just wanted to show you, okay, we have these component up and running in the control manager, right? Let me just discuss what is happening. Let's say if I just say cube run nginx dash dash image equal to nginx. So it says that there is one pod called nginx created. What this command does is this command is just running a container called nginx, and it is using that image is from the image nginx, right? So if I'll show you, so in default you can see I have my nginx up and running, right? But it is up and running, right? But what happened exactly behind the scene when I run this kubectl run nginx, right? What happened, right? So similarly, if you see using this, being a admin using the kubectl command, I have run a command called kubelet run nginx dash dash image equal to nginx, right? That's what I have run. So it took it take my query to the API server, right? Now kubelet, if I just say kubelet, take your query to the API server, right? And API server then interact at the same time to the etcd, gives the pod definition. Okay, I have a query to run a nginx container, nginx pod, right? So you need to restore that information. Similarly, it went to the scheduler, right? Give instruction that okay, you need to schedule a pod on the node, right? And which node? It will talk to the controller, right? Because controller knows what all nodes are up and running, what is the resources there, right? Then it again give this to a agent called kubelet, which is on worker node, right? And finally, using the container runtime, it scheduled your pod on that particular engine, whatever the container runtime engine you are using, right? So that's the high level view or the overall story which is happening behind the scene. Okay, so yeah, that's it how it works, right? Because this is something that we need to understand, okay, how it is, because the controller will keep on track, right? Keep on track on your worker node. It has, I think by default it is just giving the monitor period is 5 seconds. In every 5 seconds, it will check whether the node is ready or not, right? And then if that particular node is not replying right within the 5 seconds, I think then it will just give you a kind of a 40-second grace period. Like if in next 40 seconds, if a node reverted back, okay, I am alive, then control manager under that node controller, right? That keeps that node as a healthy. If in 40 seconds it never acknowledged, right? It will not gonna acknowledge, then it will mark that node as a not ready, right? Now that is fine, right? But now a question is, let's say that is happening fine. But what will happen to the pod which is already running on that node at the time when it was healthy, right? So what will happen is after the 5 minutes, right? After 5 minutes, because why 5 minutes? Because after 40 seconds, it marked that that node as a node healthy. That is fine. But being admin, you have put your monitor or something, you got the alert and you will check, okay, what is happening. Maybe there is a time that, or maybe there is a possibility you can still recover that node, right? If not, nobody acknowledged that, right? So what will happen is after 5 minutes, controller will evict those pods which was running on that unhealthy node, and they will gonna reschedule using the scheduler on next healthy node. So that's how that the actual mechanism of this Kubernetes orchestrator work, right? And that's how that Kubernetes was launched on top of Docker, because these were all facilities were not possible in Docker. Though we have Docker Swarm, right? Because I have a very good beginner course to advance on Docker and Docker Swarm. You can go and watch that series if you wanted to understand the more on the Docker, right? But yeah, that is the orchestrator feature which we get in the Kubernetes. All right. So that was the Kubernetes stuff, Kubernetes architecture, right? And I hope you like this content, right? Because this is something that which we need to understand, right? Because it may look complex to you, but idea is simple, right? Control plane makes a decision, and worker nodes do that work, right? And that is the constantly communicating between the worker node and your control plane node, right? Because it needs to, or it has to match your desired state with the current state. That is the that then only we will reach, or we will meet our goal for that orchestrator or the self-healing replica controller, right? All right, guys. So I'll take a pause here for today, and we will start different analogy or different object. What is pod, replica set, deployment, everything in the next video. And till then, bye bye. You can just go through, you could try to set up your lab. I hope you already set up. If not, I have already released the video where I deeply talk about how you can set up your lab on local or maybe on cloud as well, right? Because I'm running in this on the my local stuff. You can see that Kubernetes master and Kubernetes node 1. I have this mini cube as well, which I already shown how I have set up it, right? And going forward, we will set up one more machine here where we will just try to add as a node 2, right? And probably we'll just to see if one of the node is goes down, what will happen to those pods, how it will gonna mark as a not ready and everything, right? That everything will go on scale and we will cover slowly, right? Because we need to be master in the Kubernetes. Okay. So that's it, guys. I hope you like this content, and if you like, then please support me to subscribe my channel and share it with other buddies so that everybody will understand what is Kubernetes and how it works. All right. Thank you, guys. Take care. Bye bye.